In this question, what we've been asked to attempt to work out is the relative atomic mass for a sample of, in this case, silicon. And in this example, we've got two isotopes. So we've got 28 and we've got 29. And what we're going to try and do is figure out, well, actually we'll get to that. I'm just going to go into the question. So we'll start off with looking at what are the relative isotopic masses of each of the isotopes, and looking at the corresponding percentage abundances. I could color code this, I guess. So if we just, so this is the first one, and this corresponds with this, and this is the second one, which corresponds with this. That does make it a bit clearer. And what we can then do is effectively, well, what we need to do anyway, is effectively multiply the relative isotopic masses with the respective percentage abundances and then sum that, right? So 28 multiplied by, and then here 69.72 plus 29 multiplied by, here we've got 30.28. And well, if we do that calculation, what are we going to get? Well, if you get a calculator, I would invite you to have a go at working that out yourself. And if you do that, what you should come up with is 30.28. Now, what do we need to do next? Well, we need to figure out if the percentage abundances actually add up to make 100. Some of you can work this out maybe from inspection, but I would invite you, if you cannot work it out from inspection, to and I'm just going to quickly color code this as well, just so you can see where this came from exactly, right? So 30.28. I mean, if it wasn't already clear. Now we're going to add these two, right? So 69.72 plus 30.28. When we get the sum of these two values, that is what we need to divide the 2830.28 by, right? As you may be aware, this can add up to 100, and I mean in general, not specific to this question. The percentage abundances can add up to 100, but sometimes they add up to a number which is not 100, and this is why it's important to check. In this case, if you do this calculation, you will find that it does add up to 100. And so this number here, which as you know came from this, we need to divide that by 100, right? So divide that by 100. And when we do that, what do we get? Well, we get 28.3028. And then we ask ourselves, is this our answer? We've done the adding, we've divided it by the total percentage abundance, as we would. So no, it's not the answer yet. Why? Because the question is very specific in what it asks for, and it says if your answer does have decimals, give it to 2 decimal places. So at the moment, this is what, 4 decimal places. So we need to round this to 2 decimal places. So that's going to give us what? It's going to give us 28.30 effectively, right? So that is going to be our answer. Okay, so yeah.